So we've just come up through the periddotites, and now we're in the thrusted Cretaceous carbonates. And the thresh sheets are so dramatic with the beds and the palm trees and date trees in here. Just very spectacular. We're in a wadi, and the steep cut in between the thresh sheets makes very dramatic vertical relief.
Yeah.
Down.
Yes.
Wow.
On this side,
Right here.
this is it.
Yes.
Yes.
Okay, we were collecting these.
Yes.
Let us lift it higher.
So you very clearly see this silicicite, and then as you move down from the silicicite, you come into these carbonates. This is the Bua carbonate. And they're deep, like turbiditic carbonates. So that's deep and that's deep. Then you have
So this is the Cambrian Silicilite.
And you see almost organic material in it. See that black lens?
Yes.
Where it's cut into?
Yes, 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 yes.
Yes.
I see.
But you'll see the contours. You can walk it.
Sure. I'm getting the perspective.
We are going to discuss the riddle of the silicilite. So Laylann, tell us, what is so special about the silicilite?
Okay, so initially the silicilite was, when we drill in the subsurface, we find it encased in salt. And the riddle was, how do you have such deep water silica laminated sequences sitting in the middle of a salt basin? And the first initial model was you must have a rift, there must have been a rift basin, and you deposit these deep water rocks on top of a salt subca, and then you, as it shallows up, you redeposit the salt on top. But actually, what we now see, and especially from a lot of work done by Dr. Irena Gomez, when she mapped here, we see that the silicilite is also part of the Bua formation. And recent drilling also done by Occidental Oman, we hit the same sequences, the silicilite in the salt, and then we hit it again below the salt. And we believe this to be a tectonic repetition and not some rift basin in the middle of a subca. And there's no evidences for the rift. When you drill below, you see even from the seismic that there is no rift faults, there's nothing like that. And how do we create a rift basin when we are in the middle of a compressional regime, which Irena also shows in her paper, where, and also Kozi, there's a paper by Andrea Kozi where he shows that the Oman plate collided with the Arabian plate during the Ara times. So it must be most likely a thrust and not a rift margin.
And no one has found the evidence of the thrust? It seems like you would be able to find something like that.
In subsurface, no. You don't see the faults because you can't image well below the salt.
Oh.
The salt sucks up a lot of the seismic energy, so it's very hard to image very clearly below the salt. And
So-
initially, this was thought to be a different age silicilite than the salt silicilite. So they thought there was two different silicilites in Oman, but now we're seeing no, that there's one silicilite but repeated. Well, that's the
So let's talk about the economic significance, the hope that this can produce.
yes,
So very good porosity, micro,
porosity.
very fine grained porosity, and with new techniques. What were you saying about the porosity?
So
Very high?
it's microcrystalline porosity, so it's very high and it's very fractured already, as you can see, and it is also fractured in the subsurface. This rock does produce, it has produced when it's thrusted into the salt, and there have been attempts to produce it pre-salt, but with minor rates. So the idea is, can we form a technology where we produce this with, because there is organic material here. Is it a source rock reservoir mixed system? So it's very similar to like the shale oils. We just need to find potentially the right technology in which to, I mean, this rock is widespread, very thick. So if you can produce, you're looking at billions of barrels.
Has it ever made shows or that people have ever been able to see oil, or do you, when you make a
Yeah.
thin section, is there some oil in it at all?
Yes, there's bitumen, and we have produced oil from this rock, both PDO and oxy.
Yes, so with hydraulic fracturing and some of the
Yeah.
multi-stage, maybe there's a way to enhance the production, and it exists over many thermal maturities, so
Yes.
there's opportunities
Exactly.
for a wide range.
As you go towards the western margin, it's deeper, and PDO have produced different oils with different APIs, and it's all to do with the different maturity. As you shallow up, yes, it's much heavier and hence much more difficult to produce.
So if we go put our hand out, is it the red rock that we need to?
It's the whole.
Take
It's this
the
whole
whole
unit.
thing.
Yes.
It's
The
the
red
whole
is the
thing.
weathering, but it's this whole unit basically, and it's very laminated. And some laminations are more organic rich than other laminations.
Wow.
You can see here. And when we drill in it, sometimes we drill up to 1,500 feet of this unit in vertical thicknesses.
Wow.
It's big. It's huge.
And so there's a bit of a yellow facies. Maybe that's just weathering.
Yes. Or it could be sometimes what we see, and this is what also reports, that you get some carbonate beds, turbiditic beds coming into this deep basin.
Ah, of course,
Yes.
makes sense.
Some
this is-
brecciated carbonates fall into the basin as you're filling up this basin.
Would this be some sort of candidate for another PhD thesis?
There has been some PhD theses, but based on the old model. I think we need definitely a PhD
new-
thesis based on a different
a
idea.
new model,
The tech-
incorporate some seismic, perhaps.
Exactly, yes.
Yeah.
Because everyone carried forth this model that was written about in the 1990s. But with more drilling and with seismic and like drilling through the salt and pre-salt sequences and seeing the repetition, there's now a big drive to believe that these two are the same. The difficult part about this is you can't age date these rocks. There's nothing you can age date. So you can either age date the rocks below it, the carbonates below it, or the carbonates above it. You can't specifically age date these rocks. But there has been some work done with chemostratigraphy, and on chemostratigraphy it aligns up very well.
Interesting.
MIT, she worked with John. She used to be John Grodzinger's student, and she worked on the BUA. So she then came up with, she now is studying the silicilite, plus some other PhD students like Ibrahim Al-Rujaibi has just published a paper. And they're trying to discover if this is a chemogenic deposit or a biogenic deposit, and they believe it must be a mixture of two. Somehow the ocean waters must have been heavily saturated with silica during that time, and there must have been some kind of bacteria, because there's no signs of algae here. There must be some kind of bacteria precipitation of that silica from the ocean water. So they believe it's a mixture of two.
Does it
Because we have organic material, we have bitumen, but we don't see kerogen. That's another interesting factor. In most of the rocks, when we believed it was a source rock, we did not find kerogen, but we find bitumen. And there's an idea that bitumen is a source rock of this organic material.
And the age, is there anything to do with ice house conditions? Does any of the temperature make a difference maybe for this chemical situation?
I wouldn't know that, to be honest with
If
you.
we know
it's
the
an
age.
interesting factor to look into.
Well, we know when the ice ages are.
Yeah,
Does the age of the silicilite possibly coincide?
I need to check it. It's around, you're looking here at around 500 to 450 million years ago.
500. So we know that there's a 750 and a 700 and a 650 for the ice age, and then there's another one, 540.
Yeah, it's close to 540. It could be very close to 540 in age.
Okay.
Oh, you.
So we have a very special opportunity today to talk to Dr. Laylann Al Kharusi, our dear friend who we met in our Super Basin conference, and we're here talking about Oman geology, and we're at an outcrop of silicilite, and there's a controversy, and controversies are really exciting because that's where we learn. And when we were talking, it reminded me, in the United States we had a major controversy, the taconic orogeny. People, the taconic crush sheets, they couldn't quite tell the ages, and there were huge debates, and there weren't enough fossils, and so it took a long time to figure things out. So here in Oman, with this rock, tell us a little bit about the thinking and how it's changed, and some of the new possibilities.
So this rock is, you see it twice in the stratigraphy of Oman. You see it once pre-salt, and the pre-Cambrian, Ediacaran period, and then the second time you see it is encapsulated in the salt. Initially we thought that there was two times we deposited this silicate rock, which we call a silicilite, not for any other word, that it's made up of 99% microcrystalline silica, so it was called the silicilite based on that. And so they believed it was deposited twice during the geological history, one at the Bua time and the second time at the Ara salt time. And to explain how you see the thick silica, almost over 1,000 feet thick of silica in salt, the model was you must have had a rift basin spreading, many rift basins happening within the salt, because we find pockets of silica in the salt. We don't find it everywhere. We find pockets, random pockets in different places. But through the last 10 years, where Oxy has been doing a lot of deep drilling, and as well as other companies, we drilled through this in the salt section, and we drilled it again in the pre-salt section. And we noticed that the sequences are repetitive. You start with a base shale, you go into the silica, and then you cap off with a carbonate. So this looks like very typical of a repeated section. And Irene Gomez was one of the first people to initiate the idea that this could be the same silica. And based on our drilling, we believe, and the seismic, we believe that this is not a depositional rift basin, but we believe it's a thrusted silica, and the decolmant zone must be the shale. Of course, it's very hard to age date. The other thing is, what is the source of the silica? Is it biogenic? Is it chemogenic? Is it a mixture of two? Is it a source rock or isn't it a source rock? Is it a mixed source reservoir rock? There's just a lot more to discover and work on these sequences and to unravel it. And I agree, it's good to bring in new ideas.
So the controversy was salt, a big Cambrian salt, a big evaporite section, but this silicic rock entrained within the salt, but actually which originates below the salt. So how does it get within the salt?
Yes.
So there's, and the repetition is not a repeated deposition, but it's just somehow intruded or picked up into the salt. And why this is important is that this is a potential exploration target.
Yes.
It's, as you had mentioned, it's known to have oil and gas potential. So tell us about the porosity, and how would one make a tight rock like this, even though it has a lot of porosity with low permeability? How does this, what is the opportunity?
So yes, since it's microcrystalline silica, I know it looks tight, but it's actually very high in microporosity, sometimes up to 18 to 22% microporosity. There have been attempts to drill and frack, and there have been successes, but the rates that were produced were minor oil rates in the BUA, in the pre-salt section. In the encapsulated salt section, they have drilled, and because it's encapsulated in the salt, it was overpressured, and it's that overpressuring that created it to come up initially with very high rates and then very rapid declines. There have been attempts to maintain the rates or maintain the production, but they struggle even with fracking, and they realize that sometimes fracking it in the salt destroyed the quality of the reservoir. So there've been good successes in the salt, poorer successes in the deep pre-salt, but now people are looking at other ideas, sort of like fracking and other types of ways to release the hydrocarbons from here, and if it's a source rock or if it's a reservoir rock, and how they will tackle it. Also, the oil API varies in this rock. When you go deeper, you have a lot lighter oil, very light, up to 38 API, and as you come up shallower and it's not as buried as deep, you have heavier API oil, like 20, 18 API. So it's a very interesting, rock.
And tell us about the bitumen and the lack of kerogen.
Yes, so if the idea is, if it was a source rock, there is no kerogen. And the idea is that bitumen was the original source rock material. There wasn't kerogen because there wasn't organisms at that time. But they believe that bitumen is the source of the oil from this rock. Wow. But that is something I haven't heard much about, and it's something also different. So there's multi levels of interesting factors about this rock.
Yes, so many riddles, but and a little bit of controversy.
Yes.
And here's the special bonus, is we are at the Cambrian, the Silicilite, but we're at a major unconformity.
Yes.
So Laylann, would you tell us a little bit about the spectacular unconformity here?
So you see this dark reddish rocks jutting out at this sharp angle. That's your silicilite right there. And between the silicilite and the unconformity, so right above us, right above the silicilite, where you see the nose of the silicilite, you have Permian Khuf rock, carbonate rocks. So here you have Permian age rocks, here you have Cambrian, Ediacaran age rocks, and in between the two, what you actually have in that rubble area is volcaniclastics. The Ara volcaniclastics, the initiation from the Ediacaran boundary, you have the Ara volcaniclastics. So you can see it better on the other side of the wadi, but this is part of the interpretation that we had collision at that time. So the Oman plate, which was with the Indian plate, collided into the Arabian plate, and hence in Saudi Arabia and the other parts of the Middle East plate, you don't see any of this. They don't have salt, they don't have silicilite, they don't have the BUA. So and Andy Qazi, his paper shows that these sequences, these Precambrian sequences, match with the Indian plate in Rajasthan and all of that. So he believes that initially the Indian plate collided with the Arabian plate during the Cambrian times, and then the Indian plate broke off and Oman was left behind, attached to the Arabian plate, where we have the Western Deformation Zone.
Very nice. Yeah. So we know Andy Qazi very well, and it's exciting to realize his contribution. And so earlier, just to be precise, so the age of the salt is Cambrian, but the silicilite is older, is Precambrian.
Yes.
And so there is some silicilite entrained in the salt.
Yes.
So one interpretation is, if the silicilite is in Cambrian salt, it's contemporaneous, and that silicilite is Cambrian. But what the other theory suggests is that it's all Ediacarian,
Yes,
and it is just
tectonically repeated.
tectonically.
And is there any salt preserved on the surface at all? No.
No, I mean there is salt, not here,
Yeah.
but there is, because here we have the volcanic clastics and then we have the unconformity, so we didn't preserve the salt. But there is salt in, if you go to Qarat al-Milh, you see the salt dome piercings in the South Oman salt basin, or Ghaba salt basin, I'm sorry. And you see there is a salt mine from one of these. But in this particular location, the unconformity has eroded it away.
So now that we've seen the big picture and the unconformity and the immensity, let's zoom in and just take a look at the rhythmic layers within the silicilite.
So you can see here it's very finely laminated. And sometimes you see these dark horizons interbedded with lighter horizons. Now the dark horizons have higher organic material than the lighter horizons. And this fine lamination shows quiet energy, low energy, deep water rocks. And the rock is completely 99% microcrystalline silica.
So if you put a little acid on it, it would not fizz at all.
It wouldn't, not at all.
I have a little piece,
Take back with you.
and it does just fracture it up.
You can see it, very laminated.
Beautiful. What a story. And it just goes to show you that in geology we learn, and new ideas and new hypotheses are important, because reinterpreting with new information. And you had mentioned about the seismic.
Yes.
So it's not, tell us how challenging it is to
So because we're looking at the salt is there, and you have the salt is humongous. It absorbs most of the energy from the seismic. So to image below the seismic, the salt is very difficult. The seismic is always very poor quality. Furthermore, also sometimes to image these units within the salt is difficult. The other thing is it affects the velocity modeling. So initially what you do see is when we were drilling into this salt section and then the pre-salt section, because you have faster velocities here compared to the salt, it created a push down in what was below. So it looked like there was a rift. But when we carried on drilling, we found that there was no push down. It was just a velocity issue, and everything was flat.
Nice.
So there is any evidences of rift.
Wow.
And the biggest struggle here is, as you said, we can't age date these rocks. There's nothing we can use to age date them. We can maybe age date sequences below this or above it, but we can't actually age date the silica.
Well, thank you, Laylann, for taking us to this special place.
Oh, no, it's
Special for
fine.
so many reasons.
No, thank you.
On a beautiful day.
Yeah.
So, in talking about the origin, the biochemical and the chemical, one of the things is the age of this, and does it correspond or possibly correspond to some of the big climatic changes going on at the time?
See, now that you mentioned it, Charles, I never thought about it.
Start again.
Oh no, just
It's
keep
okay,
going. I
she
cut
can
it.
edit it.
Yeah.
I never thought, now that you mentioned it, I never thought of making any connections with climate change. But I think roughly the age of this rock is around 542 million years. And you mentioned to me earlier that it is corresponding to one of the ice ages. So this is something I think we should also look into. It's definitely something I hadn't thought about, and I don't think any of us here have thought about that.
Well, to produce so much silica, and something unusual must have happened.
Yes.
And with the snowball Earth and the several very strong events, one can be curious.
Definitely. And I definitely think there's a lot more to do here. This is, if we could unlock the mysteries of this rock, and if we could unlock how to produce it, this is going to be a humongous play for Oman in the future.
So let's talk about how big is big.
Oh, it's very big. It covers most of the southern portion of Oman. It pinches out towards central Oman, and then you don't have it in North Oman, except this one outcrop here in the North Oman mountains. So big, it's very big. You're looking at, I mean, God, maybe more close to, I don't know, over 800 billion barrels. If it's unlocked and if it's possible, then that's a big if. So it definitely needs to be studied and researched because it could be a humongous play for Oman in the future.
Oh my goodness, that's very, very exciting. And so, and you also wanted to point out the carbonate too, if you would,
Yeah.
across the road.
Yes. So if you look to the right of the silicilite, what you see here is the Bua carbonates. These are deep marine carbonates of the Bua formation. And when you look at the contact, and if you get closer, you'll see that the contact is a transitional gradational contact. There's no unconformity. There's nothing indicating that this unit is any separate from this unit. So it actually looks like a deepening sequence going from deep turbiditic carbonates into this deep silicilite. And then as you get above the silicilite, you have a carbonate unit sitting right above it. It's a bit masked here at this angle. And then above that, you have the volcanic clastics at the Ara formation. And then you have that huge unconformity sitting right above where you see the cliff coming up, and those are Permian Khuf carbonates sitting right on top of the Cambrian boundary.
And the Kuf, it produces in Abu Dhabi or in Daman, or
Yes,
even
I think
Saudi
it does
Arabia.
produce in some places, yes.
Yeah, yes.
Wow, so thank you for providing the context above and below this salicylite.
Yeah.
And very exciting.